Okay, so here we go. This is our lecture for Design 300. It's Thursday, September 16th. It's week 4, and we're on our Google Meet. And so we're going to go over a few things today. Um, in general, I still want to go over a little bit more about concrete, its strength, and why we make footings and things the way we do, and why we use concrete for footings very often. Not everywhere, not always, but it can work out very well for us, and there's reasons why. So we'll go over some of those, and then we know that there's a um, calculations we've already done, but there's a Revit file in here for you to do some drawings with. So I'll demonstrate those too today. So that's what's on the list. So let's take a look really quickly. I'm going to come over here to the VMware just for a moment, and I'm going to zoom in here. And so this is a building. In this case, it's residential. And there's something called slab on grade. This would actually, right in here, this would be dirt. This, as a matter of fact, I think you'd see the dirt. I showed it over here, but it was kind of gumming up the works in the other one. So there's dirt underneath the slab, so they call it slab on grade, and that's very common. We do that especially around here with garages and things that have to carry kind of a load, because 4 to 6 inches of concrete spread out is really cool. But of course, it's not very flexible and it tends to crack. And over here, you see some sort of a floor system. It doesn't specify what it looks like, but you see concrete piers. They're in the ground up to like here. And then there's some wood, and then there's concrete footing over here. So that's really typical. And then this floor system, oh, there's so many different ways of doing floors and floor systems that, this just hasn't specified it. So we want to talk about that because the concrete is taking the load of the building and putting it into the soil. So let's see how strong soil might be. I've got a little classification table here, and that looks like it's really big, 4,000, but that's pounds per square foot. And usually when we're talking about building materials, it's pounds per square inch. And there's 144 square inches in 1 square foot, right? It's 12 inches along one side, 12 inches along the other side. So 12 times 12 is 144. So on each square inch, there's going to be one. I have to divide that by 144. So let's see what that comes out to be. 4,000 divided by 144. I didn't do that right. Try that again. 1, 2, 3 divided by 144 equals like 27. So I'll call that 30 pounds per square inch. That's really low. And this is even really lower. It's 1/4 of that, like 7 or 8 pounds per square inch. And concrete, if you recall, if you did the calculations, those cinder blocks were like hundreds, 500 to 1,000. And really engineered concrete can be up to 10, 15, 20, 30,000 pounds per square inch. So concrete is so much stronger than the soil. Why do we use it? Why don't we use straw or wood or something like that? And wood is commonly used. People sink piers into the ground, and sometimes they just encase those piers with something to keep it from doing what? From rotting. Okay, so there's more to materials than strength. There's durability and pest damage resistance and water damage resistance. And so we know that concrete, building materials that are bug resistant. And this is by a termite company. I think they kind of know what what termites are gonna eat. So concrete and stone, the most bug resistant building material out there. So that's why often um, we use concrete or stone or brick or something like that to handle those loads onto the ground. It's not because we need the strength. We could get that strength by any number of ways, but we're getting it because it's bug resistant, particularly termites and ants and roaches and things like that. Now, that doesn't mean it's perfect. If you get a crack, they'll just go right on in, right? Or if you have what they call a penetration into the soil somewhere where somebody's drilled a hole and little termites can go right up it. Okay? So now you got metals, and those are good against pests. That's really great. So that's cool. And woods. Some woods are bug resistant, particularly pressure treated wood. Of course, pressure treated wood means that they've pressurized some pretty nasty chemicals that the bugs won't eat into it, and that can leach into soil. And so overall, pressure treated wood is generally considered to be non-environmental. And then there are some composites that make you know, combinations of these and plastics and things like that. So from bug resistance, concrete is really, really good. Let's think about fire resistance. Well, look, if you want a 4-hour fire rating, that is a humongously high fire rating. Most wall fire ratings are 1 or 1.5 hours. And look, just 7 inches thick or 5 inches thick of certain types of concrete, and you have a 4-hour fire rating. Okay, now you compare that to wood, and of course, wood doesn't many woods don't hang up to that, especially as they age. Certain woods actually do very well in fire ratings, but as they age, they get worse and worse, and it's fairly quickly. And it's mostly as the oils, not the oils, the resins, the oils dry out and go away. Plastics don't do well at all. Steel does pretty well when you talk about fire resistance. Not quite as well as concrete, but it does pretty well. So concrete is both bug resistant and fire resistant, so that's good. Now let's take a look at waterproof. So concrete is not waterproof, but it is certainly corrosion resistant, which is better than metal. It's also much easier to transport, place, form, pour, create. So concrete is very, very good as that building material. Steel is pretty good too. I mean, you can do a lot with it, but you put steel in the ground, even stainless steel, and it's likely to corrode. So when you're talking about putting something in the ground where stuff is going to get up against it, concrete is pretty good. Now, concrete is porous, and so water can get into it. And if there's little cracks and water freezes, that expands and works just like an expansion jack to crack your concrete even more. And then, of course, we know from the failure of the Surfside Tower that, you can just degrade it and its loads. And if you have rebar, the rebar inside can corrode. So it's not waterproof. And most places will ask you to put what they call a vapor barrier around your concrete, underneath and up the side of your concrete, to put even one more barrier against water intrusion. So those are some of the things we always want to see. How does it do with pests, with water, and fire? And when we're talking about the foundation, pests and water are probably the two that are more likely to cause problems. And so for water, concrete is pretty good. And for pests, it's great. Now you'll see on one of these that we say that it wants a 6-inch minimum. Over here, we want a 6-inch minimum between the soil and where wood starts to come into play with the flooring and the walls. And that's because termites generally can travel 4 inches in the air and then they dry out and die and come down. So we want to have at least 6 inches before you get to the wood of air for them to travel over. Although if it's slab on grade, we consider that they just, you want at least a 4-inch slab so they can't just kind of like crawl up the outside of the slab and get in. So that's really, when we talk about concrete, we want to talk about even more than just its strength, its durability, its long lasting, its pest resistant, fire resistant, and really for water, it does well unless you're in an environment where the water can stay in the pores and then freeze and really act like an internal jackhammer, an expansion mechanism to break that up. So that's some important stuff about concrete, and you don't have to know all the details, but you should be thinking about that a little bit. How do I make sure that my materials are going to withstand not just the stresses, but the day after day after day impingement of pests, water, fire. And we can look at that all through everything that we do. So, and these are pretty nice little, I don't know that I've put these links in there for you. I just think they're just nice to have and to think about. Another thing with concrete, if you're in a certain area, you can put coatings on the concrete to make them waterproof. Those tend to make things slippery, which it could be a problem. And they tend to degrade after a number of years and you have to redo it. So there's no easy one thing fits all determination. You have to sort of think all of those through and find out what is the best design for what you're going to do. And in our area, in the Sacramento Valley, and really most of California, we tend to use concrete foundations. Now, there are other things. I could use stone. I could use brick. I could use adobe. Those would all handle the loads. Adobe tends to break down fairly quickly with time under a heavy load, and so you wouldn't use adobe so much. But there are places that use bricks, or bricks on top of wood, or bricks on top of gravel. But laying bricks well takes an incredibly large amount of labor compared to pouring concrete. Pouring concrete still is labor intensive, and it's skill based. You can't just have, someone that's never really poured concrete out there and form it up and pour your concrete and think that your foundation is going to be good. There's skill. And if you do have work done, I always suggest that you really look into your contractors, make sure they're licensed, they're bonded, and you want to see recent work and older work because concrete does crack. And particularly if it's poured in certain ways. But that's why concrete is used instead of, say, brick or adobe or some of those other things. And metal is pretty hard to use underground as your foundation too. So that's why we use concrete a lot around here. We don't tend to just sink 4x4 or 6x6 posts into the ground and set them. We tend not to do that in California so much because we have some pretty strong environmental rules, and so people are concerned, of course, that the wood will rot out where it hits the ground, where the water and the pests can go, particularly if it gets wet then dry, then wet then dry, and bugs attack and bugs go away and bugs attack. So in general, wood is used where appropriate, where it's up away from the ground. We rarely around here just sink wood into the ground. However, it's certainly strong enough. Certainly strong enough. And if it's appropriate to your building construction, I've seen it done. People make back in the 60s and 70s, there were a lot of people that were making telephone pole houses and constructions because the power companies were replacing wooden poles and they wanted to get rid of them. So people would put them up at the corners of their house. And I mean, you could hang hundreds of thousands of pounds on a telephone pole. They're really, really strong in compression. But not so much. Not so much done. Okay. So that's a little bit of a talk about concrete as used as a foundation. Oh, one more thing. This piece, again, I'll reiterate, is the footing. This is called a pier block, and this is called a post. So this kind of construction is post and pier. Here, the footing goes all the way around the perimeter. It's continuous. Here, the pier blocks are spaced every 12-inch, 24-inch, 48-inch, whatever the structural engineer says is necessary to hold the joists properly. Okay, so these are spaced, just spaced in a grid. The footing goes all the way around. And then on top of the footing is a stem wall. And that goes all the way around. And you can imagine it's just to save money and save materials. There's no need for all of this strength all the way around. It's just too much. 12 inches wide, thousands of pounds per square inch that you could hold when I need 15 or 20. So they take the stem wall, and the stem wall thickness is set by what you're going to sit on it. What size wall are you likely to put on it? How big of an area does the joist need to sit on to take the load? So there's a lot of calculations when you get into the structural part, and they're not hard calculations, by the way. They come out of just tables that you can just look these things up because we've been doing it for hundreds of years and taking records, thousands of years and doing calculations. So this is well known, and it's not particularly difficult. I'm kind of saying that there's a lot to it. There are many steps and many things to consider, but they're all fairly straightforward. And they're just simple calculations like you're seeing in these spreadsheets that you're doing. But I just bring them up, all of this thing, the load in between here, any weight that's there has to be supported on these points out here. So depending on how far apart these are, all the load will be taken up over this little spot. And then there's just, depending on the wood or the material of this joist, this member that goes all the way across, and depending on how much deflection it can handle or you want to allow it, you'll get some different readings. Okay, so now I'm in VMware and I am in the Revit file. So this is what you're supposed to do. You're supposed to just put some annotations on it. This is a typical drawing that you would see. It's called a section view because I've cut the building. Let's see if I can find out where I've cut the building. Save it. There it is right there. See that little line? There's my building that I put on this site, and I've cut the building along that line. And I've cut the ground. So I see the ground. Here are those posts that you see. Here's the foundation and the walls. And I see some roof as I go through there. So I've cut the building, and they call that a section view. So when I come back down here, way at the bottom, here are the two sections that I can look at. So here's my section, and here's my call out. So section. There it is right there. And you can just leave all this alone. That's okay. If you're really getting into Revit, you'll find out how to space those out so it looks good and hide some of them and not hide other ones. But we're just going to leave them over there right now. Okay, but I need to do some drawing. And what you'll see is there's this little thing that's called a call out that says, here's the overall section, and I'm going to talk about it. But then I'm going to zoom in on this, and I've placed it on sheet 2, or a view 2 of sheet C106. Okay, so what view number on the page is the top bubble, and what page to go look for. So if I went to page C106, and I went to view number 2, I'd see that call out. So that's how it works. And so if I go to my section number 1, I'm just over in my project browser. And remember, if you lose your project browser, you click this View tab and the user interface, little arrow, and you make sure that the project browser is showing. And that's what you do there. And it says there's 2 things you should say: footings and piers per structural calculations, and that I want my floor to be 6 inches minimum above the soil. So those are just 2 notes. And I want those notes on my call out itself. Okay, so this is just a typical markup that you might see. And it doesn't let me copy it. I can copy the text though. I've highlighted the text and copied it. And so I'll go to my foundation. And remember where that was? It was in annotate and text. And here's that leader. I just need to go like that, and I can do a control V, I think. Nope, I didn't do that. That wasn't good. So I have to go back and see what it said again. Footings and piers per structural calcs. And I don't want it that big, but footings and piers per. There we go. And I can leave these big like this, or I can make them a little bit smaller by editing it and maybe changing it to 3/32 Arial. Yep. See if that did it. I want to is 3/32 of an inch. Just so it's not quite so huge. That's better. And the other one says 6-inch min above soil. So I can do this one just to say 6-inch min above soil. I can move it if I want. There we go. So let's see how it looks like on my foundations page now. I get rid of this one, and this one, and this one, and this one. Up. Things aren't showing up very well because it's outside of the box. So let me go back. I'm going to go back to my call out. Right down here, there's a little light bulb with like a T-square. I'm going to do that and see if I can get that little T-square to go. Did I not put those on? I thought I put those on there. I don't know where I was typing. Let me do it right here. Footing and stem wall per structural calcs. Welcome in, JR. And this should say 6-inch min of soil. And then I can squeeze this down to be a good size. There we go. And I'll turn the little square back off, and that should show up over here now. There it goes. That's much better looking. Okay, so this says the perimeter is stem wall and footing, and the interior is post and pier. That's on here. Oh, it's because I put them on the wrong one. That's why. This should say that the perimeter is stem wall and footing, and that the interior is post and pier. And over here, it should say something about the garage. Garage slab on grade. It's poured directly on the dirt. Let's see how it looks over here. So now I have to get rid of all the extra old stuff to get rid of my old markups. And now I've got it right. I've made those changes that my engineer wanted. Okay, so then you can put your name in here. And we now have some foundation views, a section view, and a call out. Okay, so that's what you'll do. And of course, then you'll take a snip of your work. And I think I have it. I'm not sure if that goes on to one or if I need two different snips of this to show my work. I I don't actually remember right now. Let me take a look. Do you guys know? There's the call out, and there's the foundation section view. So you can show the whole thing, and just what I would do is come back over here. Oh, I'm in the wrong one over here. Okay, so you can either, these are kind of cool that you can change the mode to a freeform snip if you want. Okay, so from in here, I'm in my snip, and I can say freeform and make a new snip. Check this out. You can just snip. Right along there. What I would do is I would put them both on there. Okay, I would show the entire thing, and then I would take that partial snip. So let me show you how I would do that. Now let me do my snip in my other one here. I might do something like this. And then I would put my snip. It's a free form. Did I not get that? Let me do that again. Go. And I would put that one in as my main drawing. That's not doing a very good job. I don't know why that keeps doing that. Let me get it out of the way. So there's my main drawing, and then you can show that you've done the good work that you want to do, and you can annotate this then, right? You would call this full Revit sheet showing both section and call out. Here's the call out where I added the appropriate annotations to the view. And you would fill in the link to the Revit file and a link to this snip. Okay, so that's kind of a nice way to be able to do it. And you could, let's see, you could even, if you wanted to, do something like that with an arrow. Like that. And you could put an annotation over here that says something. And you could put an annotation over here that says something else. So that might be a way that you would wish to arrange it. Notice I've got a little bit of room at the bottom. I'm going to make it a little bit bigger. You could put a frame around those. This one's already got a frame. Right, so just some things to make it look a little bit better, because this is too small to read. So you've blown it up. You've said what it is. You've said what this is. Of course, I'm doing it wrong because I put that one on the section view and I just did it as the callout view. All of this actually belongs down on here. Okay, so be sure to actually read these things. I'm just doing a real quick demo for you, not taking a lot of care. I could probably figure out how to fix that really quickly. Control delete. There we go. Now I got it on the right one. There we go. So I fixed that up, got it down here. Got a little bit of space at the bottom. Some people can make things overlap and look really good, and some people have a hard time with that. I have a hard time with it. This one doesn't look bad because it's overlapping onto a white area, right? If you needed to, this one could overlap into there if you felt like it, so that it was really obvious what they were going with. There we go. All right, so that's the demonstration, and it won't take you very long. There's like 4 annotations to add, but you're getting used to seeing what types of drawings are used to convey these material requirements. Now, this one's interesting. It says per calcs. So let's talk about that one a little bit. Okay, on this sheet, or on this sheet set, I'm only showing one sheet. In a real building submittal, there's usually a calculations page or a standards page or a place for a structural engineer to be able to sign their name that everything is right. And that's where they would specify this concrete. So they could either specify a pounds per square inch, or a number of sacks of cement. And what that is per cubic yard, how many sacks of cement do you use at a certain water to cement ratio. It could have a size distribution called out. It could have a ASTM standard called out. All of those are ways of ensuring that this concrete is what you want. You know, you just go down to Home Cheapo or Lowe's Quality. And of course, if you work at one of those two places, you probably don't appreciate the fact that I make fun of their names. But, you know, you go to one of those places and you grab a sack of concrete, and what do you got? There's Quickcrete, there's this crete, there's that crete, and is it mixed right? Is it not mixed right? They all give some number on it that says what their standard mix is at a certain cure time. So you can read it. But it's like the lowest grade concrete that you can possibly get. And it's prone to cracking, and it's really mostly considered fence post concrete. It's for fence posts because they don't really have a huge load on them. And the concrete is really there just as one extra barrier for little termites and stuff, and just keep the water from soaking in quite so much. So, it's not the strongest stuff. And so there will be specifications about this. There's something called the master format spec, which we'll go over in a couple of days. We'll be ready for the master format spec or in a couple of weeks. And you can look up concrete and you can actually use a standard concrete specification and fill in some numbers. And then the engineer will have specified that. But this is very typical of a detail. It's just showing the concept. Okay, this building is built like this, but guess what? You got to go look up the structural calcs. And I spelled it wrong. I spelled clacks. You guys should alert me when I do something really egregious like that. There it is. Now it's right. Footing and stem wall per structural calcs. This should really also say per structural calcs, but there's probably a pier block being called out. I just didn't put too much on this one drawing. Okay, if you want to, you can move some of this around so it looks a little bit better. Up to you to decide how much room you want to have. Sometimes, since these calculations are right here, somebody will pop the calculations right over here. Okay. Now, this isn't enough information. None of this is enough to actually build the thing. These are just typical drawings. Say in general, this is what you're doing. Go somewhere else for all the details. I got this one spelled wrong too. Oh, you guys just let me get away with all sorts of wrong stuff. I don't mind it if you pipe in and tell me that I got something all wrong. That's okay. So we don't know how thick it is. We don't know if there's wire mesh in the bottom. We don't know what the compaction maybe is underneath. We don't know the mix. We don't know if this is built in segments. Many times a garage floor is just poured in one big 20-foot by 20-foot pour. But that is prone to cracking. And so depending on where you are and what the surface is like, you might get it poured in 10-foot by 10-foot segments, 4-foot by 8-foot segments with a border around it. It's hard to tell what they'll actually do on that. Okay, and it doesn't talk about the finish or anything. So there we go. That's the that's a little bit more. This would actually need even more information that we'll talk about when we talk about floors next week. How does this actually work here? Okay, where does sealing go? Do you need any sealant underneath here? Do you need braces or clips or blocking? Does this come all the way out to the end, or does it start back here? And is there a fascia board? And how often are there openings in the fascia board? So this is a very, very simplistic drawing that we'll do more work with next week because we're going to talk about floor systems. This unit is foundation and flooring. When we look at this week is foundations and footings, and then next week we'll do the floorings that go on to that. Okay, so that's what we wanted to cover for today. Let's do a quick review to make sure that I've gotten everything. You've got a Revit job to do. Lectures will get posted here. There is a playlist. You are expected to watch all of these. I think it's fine if you put them on at 1.5 or 2 times speed. They're just good background information. Here's how to log into Minecraft. So I'm getting some answers from IT about what to do to get into Minecraft if you've got a problem. And I've just got to go over with them. They're IT folks, so they don't necessarily communicate their ideas perfectly. They communicate to other IT people and not to non-IT people. But I think I've got the idea of what to do. Um, and so here was the lecture. See, we've got a playlist. We've got the presentation for you to go through. Get with me. My calendar's pretty booked, but there's still a few slots left. There's the resource files, which you see right here. Okay, so you can get to some PNGs. Now, look, you can't just pop this in there and call that good. You have to do work. And I'd like you to do it in Revit. Oh, here's a cool one. Here's that table that I was telling you about, showing you. Here's your file, some revisions, some things like that. So got a lot of stuff for you. We have the 2 discussions. Please try to do the portfolio little unit. We've got 2 sets of calculations for you to do, and I showed those in the lecture. Perhaps I'll do a special video of it. It's very, very busy right now administratively because we're getting ready to get the schedule out. So we're going through lots of stuff. But I may make a separate video for these, but they are included in the lecture. And you've got your template. So I think you've got the whole bag, the whole kit and caboodle. Any questions right now before I stop the recording?
I have a question about the what's it called? The workplace productions
Okay.
assignments. How would you recommend I record the videos?
Okay, so let me show you a couple of ways. I use this thing called OBS, which I really, really like. And it's free, and you can set it up to record any screen that you want. It's a wonderful piece of recording stuff, and it is pretty simple to use. And I can give you links to doing that. But I thought that I had given you guys some how-tos on how to record using Canvas. Let me try to do one really quickly to show. So if you go into the discussions, and so here's what, like the job skills as an example. Okay, when you do your reply, I'll do a reply right here. Okay, there's a few things you can do. One, if you come over here, well, right here, you can just do upload or record media. Okay, and what that does is if you put on record, I have a weird webcam being shown right now. You can record yourself talking and doing stuff. So you can just do a recording right there and it'll pop right in. Okay. But another way is to go to this little cord right here and go to something called Canvas Studio. And then in Canvas Studio, you can do a screen capture, which is really cool. Now, you have to get this set up. The first time in is sometimes a little difficult, but you can get with Canvas help on that. But see how this comes up over here? And I'm going to do my screen, and I can start recording. And now, it'll start in a moment. And so now I can talk about anything on my screen. I can go over here and start doing stuff. I can go over here and start doing stuff. So I can go all over the place. And then when I'm ready to come back, I just stop. It's down in the lower left-hand corner. Bink. And I click done. and it just came onto my other screen. This shows up. It's got my recording, all this kind of stuff. I can give it a title, I can give it a description, and I go upload, and it takes a minute or two. And then it'll ask you if you want to put it right into the discussion. So continue. And there it is. So select and yeah, embed it. Put it right in there. Bank. And there it is. It's right in the discussion. So that's kind of a cool way. I don't know if you've seen that before, but you can have, whatever it is open and go to it and start talking about it and draw on it or point at it. And when you're done, you just click the done record button and it will go right into there. There it is right there. Isn't that cool? I like it. Not bad. Personally, I use this OBS all the time. And then do remember to, I got to get it out of full mode. How do I get it out of full screen mode? Here it is. Where's my out of full screen? I'm not finding my thing to enter. Well, somehow I got it stuck in full screen. So that's kind of a bummer because I can't finish it up. If I do a back arrow on it. Okay, well, I totally got stuck here. But that's how you do it. Don't go to that full screen mode. Just you got to get down and post it. I'm not able to post this one right now. Does that help out a little bit?
Yes, thank you.
Cool. Personally, I love OBS and it's free. It's cool. Okay, cool. Then I'll go ahead and stop the recording.